Hello everyone, I'm back with a new topic, that is how to convert the AC current running into your walls into DC current and charge your phones, laptops, or maybe used for running appliances at home. Here is the exact setup about how we're gonna work with the stuff. Here is the multimeter to measure the voltage. Here's the motor which I'm gonna demonstrate and show you that the current is being changed into DC. And these are the diodes. I'll give a brief description about them in the video. This is capacitor. It's a hundred. Sorry, it's 1,000 microfarad 16-volt capacitor. And here's a transformer that's gonna convert. That's gonna actually step down the AC voltages. And here's the setup. And I'm gonna use a breadboard so that I don't need to solder every wire. Let us first measure the AC, the voltage that is being stepped down. Here we start. Let us see the voltage that is being stepped down. I'm getting a 220 volt supply over here and a transformer is being used. And let's see, the multimeter reads 10.4 volts. That actually means that a 220 volt supply is being converted to a 10.4 or 10.5 volts due to this transformer. So now just test it. Here is how I've connected it. One of the wires is being connected to one end and the other is being connected over here. And here, I guess you heard the sound. Let me zoom it out. So here I've got an uninterrupted DC output. That is a 10 volt DC output out of 220 volt AC current moving into our home. This is the basic function into a charger of our phones, adapters. They all do the same job. I could have even used a capacitor over here to even improve the quality of the DC being produced, but I didn't because I had to just demonstrate it with the servo motor. But the speakers and other sensitive appliances need to be used with capacitors. Let me demonstrate to you people how it actually works. Let us assume that this is our AC supply. And what I have actually used over there is known as a diode bridge. This one's a loop. Sorry guys, I didn't explain. So let me first get on to what is actually a diode. A diode is a device that allows current to move into only one specific direction. If you change the switch the voltages and you want current to pass through the diode over this way, it won't. It can only pass through it in only one direction actually. So what is happening over here, as we know that alternating current, AC current, switches its direction 100 times a second. So let us get on to suppose that the direction of the current is in this direction for just a fraction of seconds. I'm just taking an example. So it would go like this over here. It won't go through this as the arrows being showed, it can not travel over this direction opposite the diode, and here it will go like this. I've made another diagram to prevent chaos as it would create confusion. So now let us assume that the AC current has switched its direction. Last time we took it over here, so now we'll take it like this. Here the current is traveling. It won't go through this. And here it has reached. As we can see, the appliance is here and the current through it is going in this direction, remember this. And in the previous diagram too, it was going through this. So basically we have constructed a system here which is acting like a direct current. That is, current is moving in only one direction. For some sensitive devices we can even use a capacitor over here so that it supplies the charge whenever it is deficient. Here is a graph for our alternating current, and here is when we have used diode. So basically this negative part is removed, and what we are getting is total on the positive part. We could have got an even smoother wave if we used a capacitor. It would look like this, and it could get even more smoother if you use a voltage regulator. So this is what we call a direct current, and this is alternating current. Thanks for watching the video.